Hey everybody! In this video we're going to talk about composition of two functions advanced. So for these problems we're given two functions, f of x equals x minus 2 over x minus 3, and g of x equals 4x plus 7. We're supposed to find the composition of f of g and specify its domain using interval notation. So first let's talk about how domain is affected with composition of functions. So when we do domain of composition of functions, we're doing two domain problems at the same time. The first thing is to find the domain of the input of the function, and then we're going to find the domain of the new function after performing the composition. So let's look at an example of this. So for this problem we have g of x plus 4, g of x equals 4x plus 7. Now what we're trying to find is f of g of x. So our input function is g of x. The first thing we need to do is consider the function, the inputs of g of x. Because if we can't put it into our function g of x, then we can't put it into f. We won't get anything out, so we can't put it into f. But for this case, the function there is all real numbers, right? Now the function of this one is going to be 4x plus 7. Now where did that come from? That is my function g of x, but I'm plugging it into my f equation, which is x minus 2, so that g function becomes my input x, and then 4x minus 3, 4x plus 7, again because that's g of x, now I minus 3. So the second part of finding the domain is to simplify this 4x plus 5 over 4x (7 minus 3 is 4), right? And I know that the bottom 4x plus 4 cannot equal what? That can't equal 0. So I subtract 4 from both sides. I get 4x cannot equal negative 4, divide by 4. So x cannot equal negative 1. So if x cannot equal negative 1, that means I can't initially put it into here, right? G of x didn't actually affect my domain, but I could go from negative infinity all the way to negative 1, and then I could go from negative 1 to infinity, and everything will be good. So that's composition of two functions advanced.